In the previous video, we talked about proving two triangles congruent and then using that information to show that corresponding parts were congruent. Today, what we're going to do is once we find those corresponding parts to be congruent, we're going to look at those parts and determine if there's something else that we can prove or determine based on that information. So before we get too far into it, let's complete this proof as a little bit of a warm-up to our video today. So let's start with what's given. We have AC is congruent to EC, and we have ED is perpendicular to BD, and AB is perpendicular to BD, and those are given. So let's mark that perpendicular angle, or perpendicular lines, gives us right angles. And then we also have C is the midpoint of BD. And that's down here in statement number 4 and reason number 4. But let's talk about perpendicular lines first. So if ED and BD are perpendicular and AB and BD are perpendicular, that means we have some right angles. So in our picture, we have angle ABC and angle EDC as right angles because we had perpendicular lines. So our next statement is angle ABC and angle EDC are right angles, and it's because perpendicular lines form right angles. Now, if they're both right angles, that means they're congruent to each other because right angles are congruent. So angle ABC is congruent to angle EDC because all right angles are congruent to each other. So now we get to our statement number 4 where it says C is the midpoint of BD. Well, if C is the midpoint of BD, remember a midpoint cuts a segment in half. So that tells us that BC is congruent to DC. Segment BC, here's your segment DC. That is the definition of a midpoint. And now our last statement is triangle ABC is congruent to triangle EDC. And why can we say that's true? Well, we have two congruent sides, but our angle is not the included angle. However, since that angle is a right angle, we can use the hypotenuse leg theorem. We have the hypotenuses in these two triangles congruent, and we have one of the legs congruent. So then, since they are both right triangles, we can use the hypotenuse leg theorem. So HL, hypotenuse leg. So we haven't done a lot of those, so I wanted to kind of do one and again review what it looks like. So now down here, we're going to take our proofs a little bit further. So we want to prove that point C is the midpoint of AE. So we have point C right here, and we want to prove that it cuts AE in half. So we have AB is perpendicular to BD, BD is perpendicular to DE, and BC is congruent to CD. All that information is given. And it's already marked for us. We have our right angles marked, and we have our two congruent sides right here marked. So now B and D are right angles. Why can we say that? Well, that's because perpendicular lines form right angles. And then we have angle B is congruent to angle D. Why can we say that? Well, those are the two right angles in our picture. So right angles are congruent. And then statement 4 says triangle ACB, or angle ACB is congruent to angle ECD. Well, ACB is this angle here, and angle ECD is this angle here. Those are vertical angles because we have those two lines intersecting, making vertical angles there. So vertical angles are congruent. So then we can say triangle ACB is congruent to triangle ECD. So we have this triangle up here and this triangle down here are congruent. And why can we say that? You might want to say, oh, hypotenuse leg theorem, because we have a right angle in both triangles. So that makes these triangles both right triangles. However, hypotenuse legs needs two sides. We only have one side, one pair of congruent sides. So these two triangles are not congruent by hypotenuse leg. It is angle side angle, because the side that's congruent is in between two congruent sides. So then AC is congruent to EC. Why can we say that? Well, if we look at our congruent statement, AC is the first two letters, and EC are the first two letters on the right. So those are corresponding parts of congruent triangles. So CPCTC. So because of that, we can go back up in our picture and say these two segments are congruent. Well, if those two segments are congruent, that means that this point C cuts the bigger segment, AE, in half. You have AE, that whole segment, and point C cuts that in half. So that means C must be the midpoint. So why can we say that? What allowed us to make that claim? Well, what made our claim is if we have two congruent segments, and then we have a midpoint. You could also just say the definition of a midpoint. I would normally shy away from what I have written in green here, because usually when we talk about the definition of a midpoint, it's we are given something's a midpoint, so therefore it cuts something in half. We're going the other way now. We're saying this point cuts two things and cuts a segment in half, therefore it is a midpoint. It's the converse of that, so I don't always like to use that because it can be confusing on when to use which one. So we took our triangle congruence theorem further to talk about corresponding congruent parts, and then based on that we were able to make another statement and justify it. So now let's look at example number 2. We have some given information. We have AB is parallel to DC, and AB is congruent to DC. And the reason for that is given. Let's mark this up. If AB and DC are congruent, let's mark that. And what we're trying to prove is AD is parallel to BC, and we have that last thing down here. So we know AB, this horizontal line, and this horizontal line are parallel. We also see that we have BD, this transversal. And you may say, well, that will tell us, we can say angle 1 is congruent to angle 3. those angles are not formed by the transversal and parallel line. The angles that are formed by the transversal and the parallel lines are angle 2. Let's use a different color. Angle 2 right here, and angle 4 right there. And those are alternate interior angles. They're both in between the purple parallel lines. One is above the light blue line. Light blue transversal, that's angle 4. And angle 2 is below that transversal. So alternate interior angles are congruent. And then statement number 3 says, is a blank one, but reflexive POC is a reasoning. So BD and BD are the same side in both triangles. So I'm going to say BD is congruent to DB. And again, the reason why I switched them is in the top triangle, angle 4 is where B is, which is congruent to angle D in the bottom triangle, angle 2. So that's why we had to switch them to match the corresponding part. So I'm going to erase the transversal here and the old parallel line and mark this side. That will tell us that the two triangles are congruent, and the reasoning is given to us, side angle side. So we have to make sure we write the triangle congruent statement correctly. So I'm going to say triangle DAB is congruent. Well, in the top triangle, D, right now, that angle there doesn't have a marking. So on the second triangle, I got to start at angle B because that angle doesn't have a marking. So triangle BCD by side angle side. Now we can say that angles 1 and angles 3 are congruent because those are corresponding parts of congruent triangles. CPCTC. You could also say that angle A and angle C are congruent, but that's not going to help us do anything. So now what we're trying to prove is that AD and BC are parallel. Let me outline that. So here's AD and here's BC. And if I redraw that transversal, you now see that angles 1 and 3, the light blue angles, are formed by my parallel lines and transversal. My vertically, or kind of slanted vertically, purple lines and the transversal, the yellow one, form angle 1 and angle 3. And those are congruent. Well, we know if those angles are congruent, the lines have to be parallel. So it's the converse of what we said in reason number 2. In reason number 2, we knew the lines were parallel, so that made the alternate interior angles congruent. Now we're going the other way. We know angles 1 and 3 are congruent, which means the lines must be parallel. So our reasoning is going to be a little bit different than reason number 2. So we're saying, oh, if the alternate interior angles are congruent, then the lines are parallel. Where reason number 2 was, hey, the lines are parallel, so that means the alternate interior angles must be congruent. So be careful about using the converse correctly. All right, so in example number 3, we're going to prove that the diagonals of a rhombus bisect these opposite angles. So we're given at the beginning a pretty long congruent statement. So we have EF is congruent to FG, which is congruent to GH, which is congruent to HE. So what that is saying is that all 4 of our sides on the outside are congruent. And we have that marked up here. Now, FH is congruent to FH. That's this side right here. And that's the reflexive POC. It's the same side. Now you may be saying, what about EG and EG? Well, yes, you could do that, but we're given the statement right here that FH is congruent to FH. So now what we have is we have two triangles, one up here and one down here, an upper triangle in blue and a lower triangle in yellow. So those two triangles are congruent because we have three pairs of congruent sides. Here's side, side, side in the top triangle, and side, side, side in the bottom triangle. Yes, in this instance, two of the sides are congruent to each other in each triangle. EF and EH are congruent to each other, but HG and FG are congruent to each other and congruent to the corresponding sides in the blue triangle. So we got to make sure we go in the correct order. So triangle HEF is congruent to triangle HGF. And that is because we have side, side, side. Now, what we're going to be talking about is that if two angles are congruent, or two triangles are congruent, then the corresponding parts are congruent. And we're going to have to talk about angles here because what we're trying to prove is that FH bisects angles EHG and EFG. So let's look at angle EHG. Angle EHG is this big angle here. And angle EFG is this big angle up here. Okay, that whole thing. We know now that because we have the blue triangle congruent to the yellow triangle, that these two angles at H are congruent because H is first in both of my congruent statements, and angle F in both triangles are congruent because F is last in our congruent statement. So what that tells us is angles EHF is congruent to angle GHF, and it tells us that angles GFH is congruent to angles EFH. Those are the corresponding parts of the congruent triangles. Well, if we look at this, and I'll do it in red, if we look at FH, you see that for the light blue angle, we have one arc above it and one arc below it. So each of those parts are equal. So that red line cuts that bigger angle in half. And it does the same thing up here at letter F, where you have that whole angle, the whole angle at F, EFG, and that red line cuts that into two congruent parts. So the reason why that we can say that that FH bisects both those angles, that is the definition of angle bisector. So I know that this was a bit much. Like, we're going to take our triangle congruence theorems, and then we're going to list corresponding congruent parts, and then look at those corresponding congruent parts and say, what does that tell us about this whole construction here? So these are a little bit more in depth. Even though this one only had 5 statements and reasons, it was more complicated than some of the other ones that we've dealt with. So I hope that this gives you a good head start into this. And thank you for watching. Make sure to like and subscribe.